Welcome to Smarter Everyday Oval Learning. Dear students, make your day smarter by learning the new things daily. And today I brought a new interesting topic for you students, that is from chemistry, quantum numbers. See students, quantum numbers. We are having 4 quantum numbers: principal quantum number, azimuthal quantum number, and magnetic quantum number, and the last one is spin quantum number. See students, principal quantum number we can represent it with the letter small n, and azimuthal quantum number with small l, magnetic quantum number ml, and spin quantum number ms. What are these quantum numbers? What is its use? Dear students, if you want to know the orientation and the arrangement of the electrons and the spin of the electrons and the types of the orbitals, and for these all details you have to know the complete detailed information about these quantum numbers. Now students, each quantum number detailed information, let's see.
The first quantum number is principal quantum number. It is the most important quantum number since it tells the principal energy level or shell to which the electron belongs. It is denoted by the letter small n. Dear students, and we can have any integral value except 0, that is n value, n is equal to 1, 2, 3, 4. Here n values represents that the number of shell, the first orbit, second orbit, third orbit, and the fourth orbit. And the various principal energy shells are also designated by the letters K, L, M, N, O, P, etc. Starting from the nucleus. You can see in the picture students, K, L, M, N shells starting from the nucleus, first orbit. And this number helps to explain the main lines of the spectrum on the basis of the electronic jumps between these shells. And increasing energy of the orbit from the nucleus, you can see in the picture, a photon is emitted with energy E is equal to hf. You can see in the picture those detailed students. And the principal quantum number gives the following information: the average distance of the electron from the nucleus. In other words, it largely determines the size of the electron cloud. And if you see the molecular chart students, here n value and 1 to 8 numbers you can see, these are the orbitals, and azimuthal quantum number also you can see in this picture students. And for the first quantum number, principal quantum number, k, n is equal to 1, which means that is energy shell of the lowest energy and the closest to the nucleus. And here the energy levels k, l, m, n are k is less than l, l is less than m, like that students. And the maximum number of electrons present in any principal shell is given by 2n square formula. By using that you can find the electrons. The second quantum number is azimuthal quantum number students. In this you can see in the picture each value of L related to the shape of the subshell. And students, here L value if you take from 0, 1, 2, 3 and the name of the subshell for this SP, DF respectively. Here students, n is equal to 1 and subshell will be with L is equal to 0, that is 1s orbital. And students, azimuthal quantum number or angular momentum quantum number or subsidiary quantum number or secondary quantum number, these are all the names of the quantum number, that is second quantum number. It is represented by the letter L students. And the azimuthal quantum number gives the following information, that is the number of subshells present in the main shell. Main shell, the angular momentum of the electron present in any subshell, it can give the full information about this. The relative energies of the various subshells and the shapes of the various subshells present within the same principal shell, it gives the information for this. This quantum number is denoted by the letter L, I said you previously. For the given value of n, it can have any integral value from, like this you are seeing in the picture. If the principal quantum number is 1, L is equal to 0, and for this name of the subshells, the number of the orbitals 1s. If you see in this tabular form, you can get the clear cut idea about these students. Principal quantum number 1 to 4 they have given here, and L values also they have given. And students, for this The particular shapes of the orbitals you can see in this main azimuthal quantum number, students. And to explain the presence of these fine lines, it was suggested that the electrons present in any main shell of the multi-electron atom do not have any same energy. And students, the third quantum number is magnetic quantum number. It is represented by the letter ML. Students, if you see in the picture, number of orbitals each subshell has. We can calculate that by using this magnetic quantum number. It has the integral values between minus L and the plus L with 0. And by using 2L plus 1, we can calculate this also. And students, by using this magnetic quantum number, we can find the producing line spectrum is placed in the magnetic field. Each spectral line splits up into number of lines. This is known as Zeeman effect. This may be explained by using this magnetic quantum number, students, that is M or ML. And since each orientation corresponds to the orbital, therefore the magnetic quantum number determines the number of orbitals present in any shell. This magnetic quantum number specifies that size of the orbitals, shape of the orbital, nuclear stability, and the orientation of the orbital, students. Orientation of the orbitals. By using this magnetic quantum number, you can know these following 4 things, students. And the following points, the next further information is the magnetic quantum number ML for each subshell SPDFG defined by orbital quantum number. Here L values also they have given in the picture. There are the number of angular momentum quantum states that can exist and are defined by the orbital magnetic quantum numbers. Values they have given here, students, and shells also you can see in the picture. And if you see this picture, here shells, subshells given, and the azimuthal quantum number values given, and the magnetic quantum number ML values also given. For here n is representing that principal quantum number, that is the main quantum number, students. If n is equal to 1, the L value, ML value they have given here. N is equal to 2 also they have given like this. The fourth one, students, that is spin quantum number. It is represented by the letter small s or ms. In the 1920s, it was discovered that 2 electrons in the same orbital do not have exactly the same energy. The spin of the electron describes its magnetic field, which affects its energy. And students, if you see the magnetic quantum number, it was introduced to account for the fact that the electron in an atom not only moves around the nucleus but also spins about on its axis, like the Earth, which not only revolves around the sun but also spins around its own axis. You can see in the picture the same thing. This number gives the information about the direction of the spinning of the electron present in any orbital. And since the electron in an orbital can spin either in the clockwise direction or in the anti-clockwise direction, if you see in the picture, students, same the directions. Hence, for a given value, m and s can have only the 2 values, that is plus half and minus half. These are very often represented by 2 arrows pointing the opposite direction, that is upward direction the arrow mark and the arrow mark downward direction. This quantum number helps to explain the magnetic properties of the substances, students. And a spinning electron behaves like a micromagnet with a definite magnetic moment. If an orbital contains 2 electrons, the 2 magnetic moments oppose and cancel each other. You can see the magnetic directions in the showing the picture, the south pole and the north pole, and the spin values also you can see in this picture, students. Thus, in an atom, if all the orbitals are fully filled, net magnetic moment is 0 and the substance is diamagnetic. And the study of these quantum number briefly in this I'll explain, students, and furtherly how can we calculate the 4 quantum numbers, these 4 quantum numbers for the orbitals. I'll explain in this class, students. Let's get into the class. For the orbital, how can we calculate these 4 quantum number: principal, azimuthal, and magnetic and spin quantum number.
Okay students, this is about the 4 quantum numbers and the complete information also. And now we have to know the finding of 4 quantum numbers for the orbitals. For example students, if I give you the orbital 3d5, the 3d5 orbital, for this you have to find out the principal quantum number, azimuthal quantum number, the magnetic quantum number and the spin quantum number. These 4 values you should find out for this orbital, that is principal quantum number n and the azimuthal quantum number L and the magnetic quantum number ml and the spin quantum number ms. These 4 values you should find out for this 3d5 orbital. How it will be, let's see. For this, according to azimuthal quantum number students, L value and the name of the subshell you know. The name of the subshell SPDF. For that, L value from 0 to 3, 0, 1, 2, 3. Let's do for 3d5. 3d5, what is n? N is the main principal quantum number, that is the first quantum number n. So students, if you see in the NLX method in the place of n, here 3 number is there. 3 is there. So in the place of n you can take here the number 3. So students, and L means azimuthal quantum number. Here L is azimuthal quantum number. X represents the number of electrons here. X represents the number of electrons. And students, for the azimuthal quantum number L, if it is d orbital, that means d subshell. See here d subshell, the L value is 2. So you can take directly the 2 number here, L is equal to 2. Okay students? For the third quantum number, that is ml, for that ml means d subshell it is having, so d subshell it has 10 electrons students. That means how many orbitals it must contain students? That is 1, 2, 3, 4, 5 orbitals. Why? Because if it is 10 electrons are present in the d orbital, d subshell and totally 5 orbitals must be there for the occupying of the electrons. So that if you take the middle of that one 0 and here all the positive integers and negative integers like this, LHS and RHS. If you take like this and the middle one, the number is 0, 1, 2 and -1, -2. If there are 10 electrons, so occupying of the 10 electrons must be there. For suppose here we are having 3d5, so in the place of x 5 is there. That means there are totally 5 electrons are there. That means the arrangement of the 5 electrons should be like this: 1, 2, 3, 4 and 5. So all these electrons which are having in the upward direction spin. So the last electron is reaches here, that is number 2, that is the value of ml, that is the magnetic quantum number, the value ml. And students, this electron has the spin upward direction, so clockwise direction, so that ms value has plus half. If the last electron has the downward direction, if you take that value minus half. Okay students, and let us take the another example for calculating all these quantum numbers. Let's do the another example. The next example what I have taken here, that is 4f11. Here NLX method in the place of n 4 I have taken, so that for this orbital 4f11 orbital we have to find out the principal quantum number n and the azimuthal quantum number L and the magnetic quantum number ml and the spin quantum number ms. Okay students, and in the place of n we are having 4 here, and this is f subshell, and for this if f is subshell f, the number of L value must be 3. And students, for F orbital there are 14 electrons. That means how many orbitals will be there, students? 14 means that is 7 obviously. 1, 2, 3, 4, 5, 6, 7. 7 orbitals must be there for the F subshell. And students, I am doing the arrangement here. In the middle one, if you take just like 0 and 1, 2, 3, minus 1, minus 2, minus 3. And the LHS and RHS you can take like this, positive integers and the negative integers, students. And see, if there are 11 electrons, you can draw the arrangement like this: 2, 3, 4, 5, 6 and 7. 7 electrons which are having the upward direction, students, spin. And 7 and 8, 9, 10, 11, students. The 11th electron is reaches here at 0. The integer value 0, then ml will be 0 here. Then the last electron with downward direction, that is anti-clockwise spin, anti-clockwise direction, so you can take the ms value is minus half. Minus half is the ms value. Okay students, this is about finding of the 4 quantum numbers for 4f11. We can take the another example now. The next example what I have taken here, 2p5. So according to analysis method, in the place of n, that is the number 2. Okay students, and azimuthal quantum number in the place of L, we are having p subshell here. For the p subshell, what is the L value, students? 1. And for p subshell, there are 3 orbitals. Why? Because p subshell, it must contain 6 electrons, so that there are 3 orbitals: 0, 1, minus 1. These are the integer values we have to take like this, students. And for this, here 5 electrons are present. So 1, 2, 3, 4 and 5. This is the last electron, 5th electron is reached here at 0. So that ml value, the magnetic quantum number value 0. And students, the spin quantum number, see, if you see the last electron which is downward direction, that is anti-clockwise, it is located here, so that the value must be minus half. Okay students, this is about finding the quantum numbers, 4 quantum numbers for the given orbitals. And you can take the number of examples for this, you can practice. This is about our today's session, students. Your opinion, you can convey your opinion and your doubts also in the comment section, students. And if you like this video, please share to your friends and subscribe to this channel. Thank you so much. Please subscribe to this channel and click the bell icon for my further updates. Thank you students. Thank you for watching.